So we've got a lot to talk about, and I apologize for not having slides. Hopefully we'll get that going back soon. So I've got this awesome picture of an iceberg here. I want you to imagine, so a lot of the SCA vendors, the software composition analysis vendors, will show you an iceberg and they'll say, look man, 80% of your application is libraries. You got to focus on the libraries. Well, they're wrong. They are about 80%. It's actually about 79% on average of your applications is library code. The problem is only a tiny percentage of that code is actually used. 72% of libraries are never invoked. That's a crazy number, by the way. They're all compile time dependencies and other kinds of code that gets bundled into your application and deployed, and it never gets called. And we know because we measure applications as they're running. That's one of the things that we do. So across 10,000 applications, we've got a ton of data on what actually happens. So that's one thing right off the bat, is your application is mostly custom code. 3/4 custom code. 8.5% is libraries that are actually invoked. We call them active libraries. So that's one thing, is you want to focus on the important parts of your application. And the second thing is when you look at where vulnerabilities fall, almost all the vulnerabilities fall in the custom code. Average 26.7 vulnerabilities in the custom code, and only 1 or 2 vulnerabilities on average in the libraries. Now, I am not saying that libraries are an insignificant problem, and this is probably the wrong week to be making this point, but really focus on your custom code. That's where the most critical vulnerabilities are, and really where you should spend most of your effort. By contrast, the library problem is relatively simple to solve. So let's dig in and take a look. No bueno? This is really going to be fun. Okay, so the first thing I wanted to commend to you is a paper by a guy named Ken Thompson called Reflections on Trusting Trust. Has anyone read it here? I figured Jeremy, probably a couple others. This is a 3-page paper, and it'll blow your mind. So so you got some nods over here. If you have not read this paper, it is on your now to-do list because it's fantastic. And essentially, he tells a thought experiment about Trojaning a binary compiler that will automatically Trojan the login program in Unix. And so the levels of indirection here are that there's no source code with the problem in it anywhere, and yet future versions of the compiler and future versions of the login program, it automatically Trojan with this stuff. And his conclusion is, and I'll read you this quote, he says, the moral is obvious. You can't trust code that you didn't totally write yourself. That's a pretty dangerous message in a world of massive library downloading. And he said, especially from companies that employ people like me. So interesting observation here, and we'll come back to this point as we go forward. So I want to spend a few minutes on Equifax because we kind of have to. This is a serious supply chain problem. So the first thing is a little background on Struts 2. It's a framework. It basically allows you to build web applications more easily by providing all the plumbing. And it's kind of in decline. I have some stats here. Currently, Spring is like 72% of web applications, and Struts 2 is down to like 4%. But a few years ago, it was pretty big, and so there are a lot of Struts 2 applications out there. Struts 2's had some pretty serious CVEs, and we'll dig into a few of those. I've got another great slide here that shows all the Struts dependencies. So there's there's probably about 100 different jars here on this page. And some of them are compile dependencies, some are test dependencies, some of them are transitive dependencies. So if you're not familiar with what that is if you include a library in your application, then that library may include libraries and libraries included in that. And so when you actually compose your application, all of those jars get pulled together into your application. And so we've had an explosion in libraries over the last 10 years. I'm going to show you this beautiful iceberg. See, with stats and arrows, and thank you. My graphics design person did that for me. Ken Thompson, Equifax, and so, okay, so here we are, struts 2 dependencies, and those not intended to be readable. The point is that this is all inscrutable. I love the focus on that. Is that me or is that the slide? Okay, maybe we can get somebody to work on that. Okay, so this is really distracting. I'm just like, okay, so there were some struts vulnerabilities, right? Back in March, there was a serious vulnerability we're going to spend some time on called 5638, all right? Then in the last week, since the Equifax incident came out of the news, there have been 4 more struts 2 vulnerability released, 2 of which were highs. It's pretty difficult to get a CVSS score of high. You've got to really try. And these are all, remote code execution vulnerabilities in the single library. Now, I want to caution you here, just because a library, I did that on purpose. I did that on purpose. Just chill, everybody. We're all good. Just because a library has known vulnerabilities isn't necessarily a bad sign. And I want to be really clear about this. A healthy software project will be discovering vulnerabilities. So if you see a library out there that has no vulnerabilities posted ever, probably nobody's looking. So I just want to be really clear. Just because they have a lot of vulnerabilities isn't necessarily a bad sign. In fact, it's a sign of a healthy project that's getting better. So I don't know if you actually read this CVE, but it's actually kind of interesting. It says here in invisible blurry type, it says possible remote code execution, possible, when performing file upload based on Jakarta multi-part parser. So I just imagine this conversation at Equifax, and this is purely hypothetical, but I'm imagining like, hey, there's a new CVE came out on struts 2. Are we vulnerable? Hold on, well, it says it's possible, I don't know, and it sounds like it's a file upload problem. We don't do file upload. Okay, cool, we're good, let's go. And they just don't do anything about it, right? I can totally imagine this happening, because this is how, there's multiple CVEs every week that you have to evaluate and decide whether you're vulnerable or not. How are you going to figure it out? It's not as easy as the press is making it out, and that's really an important point here, right? I imagine that Equifax has, 50 of these applications out there. So here's what we saw. 5638 gets released, disclosed in March. Almost instantly, we started seeing wide-scale attacks coming from around the world, from Singapore and India and China and so on. And if you could read this, there's a big expression language injection in the content type header. You see a big expression that's got some runtime exec stuff in there. And hopefully, if you're paying attention in the crowd, you just went, what? This is a file upload problem? This isn't even a multi-part request. This is a GET request. And what the hell about expression language injection? Where did that come from? Well, that wasn't obvious in the CVE. It just wasn't there. So you can see sort of a gap in how people have to deal with these kinds of problems. So this is an actual attack from April. It's just, these happen right away and across all of our customers. So if you didn't get notified that you were under attack, then you weren't looking. And most people don't have good visibility into this. This is not something that most IDSs pick up and so on. So we're going to get to this, but you need that capability. Okay, so then everybody goes crazy, right? We have a week of congressional investigations and lawsuits and retiring executives and look, it's easy to pile on to Equifax, and I think a lot of folks in this room have probably piled on Equifax, like, oh my God, how could they be this negligent? I just want to consider that for a second. Is it automatically negligence if they didn't patch within some time period? What is that time period? Is it before the attacks start? That would have been a couple hours. Is it, I'm not there yet. Is it like a week? Is it 4 weeks? 8 weeks? I don't know. There's some legal precedent to assuming that something is negligence just based on the facts. In 1863, a guy was walking past a warehouse and a barrel of flour rolled off the second floor and landed on him, hurt him. And the court looked at it and they were like, well, can you prove it was negligence? And the guy was like, no, a barrel hit me out of nowhere. I don't know anything about what happened inside there. I can't prove negligence. And the court eventually decided, no. If a barrel rolls out of your warehouse and hits somebody, it's negligence. They call it res ipsa loquitur. The thing speaks for itself. And is that where we are with security here? Is this res ipsa? I don't think so. So let's talk about what is reasonable. So I want you to imagine that you've got a bunch of applications built with Struts 2. I think of replacing your core library. It's like ripping out the foundation of the house, right? This is an analogy to a car. It would be like taking an engine out of a 2017 Corvette and saying, well, you got to replace the engine in your 2010 car with this new engine. Well, there's going to be some engineering involved there, right? It's not just a drop in. You're going to have to like adjust some hoses and nozzles and bolts and stuff. You're going to have to make it work. That is a ton of engineering. Now, I've talked to probably 24 executives here over the last couple weeks, and none of them said they could get anywhere close to fixing this in under several months. So everyone is Equifax, really. These vulnerabilities come out, and our ability to respond is months out. So there's this window of exposure that we got to deal with, and I'm not that comfortable saying it's negligence. Now look, Equifax handled this poorly after the fact. They didn't make perfect steps here, but I also want you to understand that there is another side to this story and think about this constructively. So let's look at sort of what they ought to have done. This is A9, right? This is OWASP A9 in the top 10. I think what was negligent was not what they did after the disclosure, because I believe what I've read, they sort of tried to fix these applications, and it takes a little time. But I think what's negligent is what they didn't do before the disclosure. I think the focus here is we've got to be ready to respond to new CVEs within hours. If we can't do that, then we cannot protect our companies, because there's going to be this huge window of exposure for terrible vulnerabilities. So, this is not, A9 is not some crazy movie plot risk, right? It's, we totally understand this risk. It's been around for a long time. It was added to the OWASP Top 10 in 2013. We know this is going to happen multiple times a year. It's not just Struts 2. It is a series of things that's going to happen every month from now on to your organization forever. So we've got to be better at this. We've got to prepare. And very few organizations are good at this. So I want to take a quick look at sort of the search and patch approach. This is essentially best practice of what people are recommending. If you see up in the top right here that you can't read, that's the OWASP Top 10 snippet that says basically this. It says, look, when one of these things comes out, the first step in this actually is you just use whatever libraries you want. There's no sort of control over what libraries you're bringing in. You just say, oh, I need it. I need some huge, 10,000 module library to do some function. So I think we need to be a little more conservative in the kinds of code we adopt, and use some criteria maybe to select them. We'll talk a little bit more about that. But you need to be continuously monitoring both your portfolio and the universe of CVEs that are coming out. And Jeremy runs a project called OWASP Dependency Check, which is a very helpful tool to help you understand what libraries are in applications that you have. But don't forget, you've also got to understand what apps you have that are out there so that you can go take a look at them. Then you scan them to see if there's any vulnerabilities in using any libraries. Every time a new CVE comes out, you probably want to do that. So you're going to need to be doing this continuously. It's not something you can do once a year. You need to be doing this continuously across the whole portfolio. And then when you do discover one, you've got to update your application, rewrite the code so it works with the new framework or whatever. You got to retest it, both the functionality and security, and then you got to redeploy it out there. So this is why it takes months. This is a lot of work to go rip this out and redo it. I think there's an alternative plan. So I'm going to say this is the prepare in advance plan as opposed to the react afterwards plan. First, you're a little selective about the libraries that you choose. That is actually easier said than done. It is very difficult to know about libraries, and again, we'll touch on that later. And then the second thing is I think you have to have some kind of runtime protection as part of your applications. And I believe companies that have this protection, they will get automatic reports on all the libraries that are being used in all the libraries. That is not a complicated thing to do. Your applications can self-report what libraries they're using, and you can maintain a database so you know exactly what code is running on every machine that you've got out there, sort of a universal portfolio, so you don't have to go chasing around and scanning every app in your inventory every time a new vulnerability comes out. Second thing, runtime protection can quickly make CVEs unexploitable. So you've got a way of responding that's much faster than the search and patch approach that takes months. You need to be able to make these vulnerabilities unexploitable. Jeez, my magnetic personality. Make these vulnerabilities unexploitable within a matter of hours. And then the last thing is you need to have visibility into who is attacking you and how they're attacking you. And to me, most organizations don't have that visibility. There's no monitoring for that, and that's why so many organizations weren't aware of how widespread these attacks on Struts 2 were in the months before Equifax got breached. We've got to have that visibility so we know how to respond. I believe that with this kind of preparation, you can then respond almost instantly to new vulnerabilities that come out. Okay, so that's my thinking on known vulnerabilities in the supply chain. I want to move to latent vulnerabilities in the supply chain. So these are the unknown vulnerabilities that are still out there. So I like to think of this as millions of libraries out there across tons of different languages and environments, and there are literally dozens of researchers focused on this problem. That's the asymmetry in what we've got. And God bless these researchers that are doing this work and finding this stuff, but we're nowhere near coverage over the universe of open source libraries. It is just massive in terms of problems. There have been a few efforts out there to try to measure the security of libraries. So some tool vendors have made their technologies available to open source projects. Some have run, say, a static analysis tool on open source libraries and provided the results to the developers. Those approaches are, well, they haven't been successful. There have been also open source efforts. There was one led by Crispin Cohen back almost 15 years ago, where he started a community called Sardonyx that was like an open code review project where people could participate and sort of, crowdsource code reviews. But none of these things have taken off. Analyzing a library is a little different than analyzing an app, by the way. It's a different kind of analysis. And so finding these things is quite tricky. But we need folks to have the information to pick better libraries. And right now, that information is not available. So if someone came to me and said, hey, should I adopt Apache Commons, whatever the next Apache Commons thing is, or the next framework that comes out, I'm going to have a hard time answering them because I don't have the information, right? I don't know who built it. I don't know what process was used to build it. I don't know if the developers got secure code training. I don't know if they used any tools to help find vulnerabilities and fix them. I don't know anything about the process that they've used to manage security. I don't know if they've had it third-party reviewed by anybody. There's just none of that information is available, and that means I can't make an informed decision about the security of these libraries that I'm trusting my enterprise to. One thing I think I skipped in the sort of the non-slide section of this talk is that these libraries run with full privilege of the application. Okay, so when you run any one of these libraries, it's part of your application and it has the capability to do anything that your application can do. So you're bringing in a library like log4j, you think, oh, harmless, it's a logging library. Well, actually, that logging library can do anything that your application can do. It can access your database, it can extract credentials, it can stream your sensitive data out to the internet, it can do anything. You are trusting these libraries with your enterprise, no question. So we need to be a little more careful, and there's no way to decide whether something's secure or not. When I worked on the ASAPI project at OWASP, we did some things to try to establish that assurance. We wrote a huge test suite. There are thousands of test cases that are part of ASAPI to prove their security. We ran tools on it like find bugs and PMD and static analysis tools. And we went and got code review from the NSA and from Lockheed Martin. And all that evidence, we made it public, but there's not a market for this. Like, nobody knows to check that. So there's no ability to compare these libraries, and it's something that's deeply broken in our software supply chain, is that we can't tell quality parts from non-quality parts. There's a famous paper called The Market for Lemons. Anybody read that? It's by Robert Akerlof, and 15 more minutes? Okay, perfect. I'll make this short then. Basically what he says is, in markets where there's asymmetric information, like if you're selling a used car in the used car market, the seller has all the information, the buyer doesn't know if he's buying a lemon or a good car. It's like software, right? You don't know if you're buying a good library or a lemon. And in markets like that, unfortunately, the price, you have to discount the price you're willing to pay down to the price of a lemon, because you don't know the difference, right? And so that means that folks selling good cars in the used car market can't get fair value. And in the software market, that means that you'd be insane to write secure code, because you can never get the value from that. So our market is broken, and it's because we don't have information, and that is why I made the OWASP mission to make application security visible, so that we can make informed decisions about risks like this. So this is really important. There is no security facts label for software, and it's something that I think could really help. Anyway, I'm not going to spend a lot more time on latent vulnerabilities. You should just know is this is not a needle in a haystack problem. This is a haystack full of needles problem. Okay? But this is a problem that all the other talks here are about, and so I'm going to move on and talk about the last thing, which is Trojan components in the software supply chain. Now, this is actually really interesting to me because, again, we trust these libraries with our entire enterprise. So if you want to be a committer to an open source project, there's 3 ways to become that. 1, you can be the original developer, so you could create your own malicious library. 2, you can be appointed by the original developers, so you just get like that guy. Or you can be successfully voted in by the community of committers. So actually, this is not really a hard bar, and you don't even have to really commit code. You can be committing documentation or participating on the mailing list. Really, by committer, what they mean is you're committed to the project, which is just a kind of interesting way of interpreting that. So same thing, this is the Apache-specific rules. They make it easy to be a committer. That's their point. It's about a community of people building this stuff. But for me, what that means is we've got a community of people that we don't know anything about. There's no background checks. All you need is a Gmail address, right? There's no background checks. There's no like training or apprenticeship or reputation checks. Like you don't have to have a 5-star eBay seller, anything like that. You just commit, right? So again, missing information in the supply chain, so we can't make smart decisions. And just so we know what we're talking about here, I'm going to point out a few examples of what I'm talking about with malicious code. This is a little chunk of code. You can see there's some commented out code here. There's actually 4 calls to runtime.exec in this code snippet. They're all hidden by simple code obfuscation. And I'll make this deck available to everybody who wants it. So you either contact me or it'll be online. But it's simple to hide flaws like this in the code and make it really difficult to discover. And I have found instances of this in open source libraries online, which is kind of fun. Here's another little trick. This is abusing the class loader. This is 2 lines of code that can turn an arbitrary set of bytes into a class and run it. Now you can bury this code anywhere in your application. You can put it in a two-string method in some obscure object. It doesn't matter where it goes. You can even make utility methods that look useful, and then this can reduce down to like one little method call. And you can take data from an untrusted source and turn it into a running class. Like if you Trojan the application this way, then you could go away, you could leave the company, you could go on vacation, and you could send a bunch of bytes into the zip code field, and bam, you've got code running in the data center of the company that you're working at. So, you know, lots of ways of hiding malicious code in applications to do things. Here's one that Trojans the Java installation on whatever machine this runs on. So you can just replace jar files in the, this replaces the JCE library. You can throw it into the ext directory, and then if anybody calls JCE or runtime.jar or whatever, now it's running your code, not their code. And so you can Trojan this not for one app, but for all the apps running on that application. There are infinite possibilities here. I mean, it's just like shooting fish in a barrel, figuring out how to hide this stuff. Here's one this is just a little chunk of code that Trojans a class file. So it'll take any class file that you hand it, and it'll backdoor it. And then I've got a JUnit test case here. Anybody, if you do code review, anybody do code reviews here? Do you check the test cases? Good, I got one yes, that's unusual. That test cases run and have privilege to modify the binaries. So you can just replace the binary before it gets deployed to production. So it's another little gap, right? Another cool thing, this came out last week, is library typo squatting. It's kind of a new thing now that repos are becoming so prevalent. These guys in PyPy made versions of their libraries, and you can see the difference. Like crypt, they made a the crypto library, they made a crypt version. And PWD hash, they made a PWD library. And like acquisition, it took me a minute, I stared at that, I'm like, what is wrong? And I'm like, it's missing an I. It's acquisition, which is a whole different thing. Anyway, so like, if you go to PyPy or do pip install or something, and you type in something obvious like URL lib, you might get the wrong library. You might get a Trojan version of that library. Uh-oh, now you're trusting your enterprise to just some random library that you didn't write. And it's easily possible in all these other repositories. It's exactly the same problem, because there is no SSL certificate that you buy for your library. Code signing is not a fantastic solution for this, by the way. This is a complicated problem that we're going to have to wrestle with if we want to build assurance in our supply chain. This is what happens if you go to search.maven.com and type in struts2. You get 265 entries. And you got to figure out which one is the right one that you want to include in your application. Anybody could put a malicious one as long as they use, like I could put like jeff.williams.struts2. And people would search for it, and maybe somebody clicks on it and includes it in their app, and then I own their data center. That's not great. So I want you to consider the number of people that you are trusting to run privileged code in your data center, right? Surely it's your developers, a handful of them building code. It's all the committers to all the libraries that you're using, and all the committers to all the dependencies of those libraries. And so now we're up to probably thousands. And then if you consider all the whole tool chain that goes into building those libraries, like what if somebody Trojaned the compiler on a developer's machine? Developer machines are not well protected. Those guys run code, like just do this. Go git clone on Jenkins at GitHub, and then Maven build it. It's like an hour of downloading code to your machine that then just runs on your machine. It is crazy how much code comes down. Millions and millions and millions of lines of code that you're not trusting. And any of that code could Trojan your code, which then goes into your data center, and then boom, you're done. And if you think that the bad guys are not smart enough to figure this out, well, I figured it out. It can't be that complicated, right? So there's a huge number of people that commit code to all those different tools in all those different tool chains and pipelines. It is staggering what's going into the tool chain. And if you think about other industries, manufacturing industry, drug industry, food industry, they have all tackled this problem. It's not unsolvable. We just have to dedicate ourselves to fixing it because it's crazy the risks we're taking here. This is bananas. We are building our company's futures on parts that we grabbed out of a rusty old scrapyard. We got to build it with better components, high assurance, trusted components for trusted applications. So I did a little experiment. I had this idea. I was like, man, there's all these source code repositories out there, and then there's all these binary repositories out there. And I was just like, do they match? I don't know. Like, they could easily be different, right? Like some developer could push the code to GitHub, and then they could just change it, build it, and check that modified Trojan binary into Maven. So I thought, well, I'll just run an experiment. And I got a little carried away, so forgive me. But I wanted to test this hypothesis. So you should know that there's not really a lot of security guarantees with these repos. It's basically like, yeah, your own risk. These are rusty parts from a junkyard. You can build whatever you want out of them. We're not responsible. So you're not getting assurance from the repos, and that is a big problem, in my opinion. So I built this experiment. I built this framework. Basically, the idea here is I figured out how to map repos to source code repositories, which ain't easy, by the way. It's not always obvious. It's supposed to be in the POM, but it ain't, and they're all wrong and broken. So I wrote a bunch of really crummy code to sort of normalize all that. And then I built a framework that would automatically build those libraries without running the tests, because I don't trust the test cases, so you got to be careful when you build stuff. I wanted to use a minimal trusted tool chain, right, because I didn't want to Trojan myself. And then I figured out how to download the matching jars. Then I wrote a binary differ to compare my trusted built jar with the jar that's in the repo, and ideally, I would have found nothing, like it would have been just all stiff. That is not what happened. It blew up like crazy. And then I realized, oh crap, there's like, 10 different compilers that people are using to build this stuff, and they all do weird little optimizations to the code that make it different. So I had to fix all that. So I made a differ that is now compiler tolerant, so it handles changes to labels. I got a couple examples here that are not going to be legible. This one of them shows like string concatenation is just different. It's optimized in newer version of Java. Same with like, one version of the compiler will do an increment by -1. The other one will do like subtract 1 from a register. So it looks so simple things like that. So I ate all that. And now I've got a differ that actually works. And if anyone's interested, I think this is a useful tool to have out there. And so the results after all that is that about 10%, almost 11% of libraries are just different between the Git repository and the binary repository at Maven. Or I also, some of these came from Apache Subversion code libraries. So a lot of differences in the code. I was surprised the number was that high, but it's an interesting little feature. Thank you. And here's some of the packages that were the most vulnerable here. And a lot of these were not malicious, right? These aren't all Trojans. They're like, maybe just as part of their process, they just did a little fix, and they didn't match the Git tag match up with what's in Maven. But it's concerning to me. Like, this indicates to me that something went haywire in the build process. To me, the build should be like totally automated. You hit a button and compiled code comes out, and that's it. It automatically tags and it's all matched up. And so the good news is 90% of the libraries out there, great. You match. I think that's an awesome result. But these ones are a little concerning. So a couple closing thoughts. I'm going to finish where I started. Every time you think about your supply chain, I want you to think about this guy, Ken Thompson, and how many Ken Thompsons are out there. There's a lot of them here these 2 days that are thinking about this kind of stuff, and this is not that complicated. It's just this huge elephant in the room that nobody's really talking about. We are trusting our futures. I'll give you a little side example here. Anybody have a rule that says developers aren't allowed to access production? Do you know how ridiculous that rule is? That's like they're writing code and committing it to production every day. That code can do whatever they want in production. They're already there. The trust model is broken if you think that developers can't affect production. I'm not suggesting you change that rule. It's fine. It's sort of one of the things, but just it's silly. We're worried about that threat when we've got this threat out there. It's like a gigantic boulder screaming towards us at 100 miles an hour, and like, hey, stop that. So, I don't know, it's just, so look, you really need to be prepared for new vulnerabilities to come out. They are coming faster and harder all the time, and Equifax was not prepared. You don't want to be there. So get prepared for new vulnerabilities. Be careful about what libraries you adopt. Build them yourself with clean tools. I call that BYOB. Some of you may understand. Continuously monitor your library inventory. This is not a once-a-year scan. This is a continuous thing because it can change daily. And make sure that you have a way to make those CVEs unexploitable so that you can respond when a new Struts 2 vulnerability comes out within the window. You have hours, and I'm sorry that's the way it is. It used to be more. You used to have months or years. Now you have hours, and that's just a fact. So we got to change the way we do things. I want to thank you all. I appreciate you attention. Honestly, the attendance in the room kind of reflects the appreciation of this problem. So help me spread the word about this, because this is just crazy. We can't do this. We can do better. If you want to help me, please just reach out, and maybe we can do something with the rest of the OWASP community. Thanks.